According to the Occupational Safety and Health Administration, fall hazards are the leading cause of injury at construction sites. More than 650 workers died in falls last year, and thousands were injured. Apart from the personal tragedies of these accidents, worksite falls also result in enormous costs to business and industry in insurance premiums, workers' compensation claims, product liability costs, and related expenses. Ensuring a safe workplace is a mandated employer responsibility. Under provisions of the Occupational Safety and Health Act, employers must provide workers with an environment free from safety and health hazards. In turn, manufacturing standards for fall protection equipment are established by the American National Standards Institute and the Canadian Standards Association and form the basis for OSHA safety regulations. Apart from compliance issues, however, the most effective fall protection programs result when employers work closely with workers to identify fall hazards present at a particular site and develop comprehensive safety at height plans and procedures. Even when fall protection measures are in place, it is important to recognize that equipment deteriorates over time, that routine inspection for wear and damage is critical, and that proper training in fall protection and equipment selection are absolutely vital. A written fall protection safety plan should be created once the specific fall hazards have been identified. The plan should specify what fall prevention or personal protection measures are to be used, and it should also identify who is responsible for implementing the safety measures, including supervision and training. The program needs to be clearly conveyed and understood by all participants. Employers should be familiar with the different fall prevention equipment options available and select based on the particular site and type of work being performed. Consultation with safety equipment manufacturers is invaluable in identifying equipment that meets specific worker and job site variables. Because all work environments differ, it is impossible for the manufacturer to determine exactly which safety at height products will provide maximum protection for each job. By understanding how fall prevention and protection equipment operates and knowing the differences in product functions, the employer can select equipment that is best suited for its workers. Every worker must be trained in the proper use of appropriate fall prevention or personal protection equipment. Training should include identifying fall hazards, selecting appropriate equipment, following proper anchoring procedures, and using equipment properly. Workers should also learn how to inspect and maintain equipment. Fall prevention, fall arrest, positioning and restraint, suspension and retrieval are the basic categories encompassing types of fall protection equipment. Fall prevention measures entail the installation of permanent or temporary barrier or guardrail systems that simultaneously protect multiple workers. This category of collective systems is typically used in building construction and other elevated areas where workers are exposed to leading edge decks, unprotected roof edges, elevator shafts, floor hatchways, chutes, or wall openings. Fall arrest equipment or personal fall arrest systems is comprised of three components that are often referred to as the ABCs of fall protection. These are anchorage connector, body wear, and connecting device. Used properly, a fall arrest system does not prevent a fall, but rather suspends a worker in the event of a fall and prevents impact with a lower obstruction or the ground. Positioning and restraint systems hold a worker in place, allowing a hands-free workspace or restrict a worker's movement in proximity to a fall hazard. A typical system consists of a full body harness with side or front D-rings, a positioning assembly, and an attachment point. Suspension systems enable workers to be lowered and supported to accomplish hands-free tasks such as building maintenance functions. Typical components include a full body harness, a connecting device or work line, a suspension device such as a chair or sling, and an attachment point. Retrieval systems are used in storage tanks, manholes, and other confined space applications. The system includes a full body harness, a retrieval device, a connecting device, and an attachment point such as a tripod or Dura-hoist system. The three key components of the personal fall arrest system, must be in place and properly used to provide maximum worker protection. Anchorage connector, body wear, and connecting device. An anchor point is a structural item such as an I-beam, scaffold, rebar, or lifeline to which workers are affixed when a fall hazard is present. It is sometimes referred to as a tie-off point. Anchor points must be carefully selected since their strength and stability are dependent upon in case of a fall. To avoid a dangerous swing fall, workers should always try to connect and work directly underneath an anchorage point whenever possible. An anchorage connector is an intermediary fall protection device, such as a cross-arm strap, D-bolt, or rope grab that links the worker to the anchor point. Anchorage connectors are offered in a variety of configurations to accommodate vertical or horizontal connections for attachment to concrete substrates, large and small beams or scaffolding, rooftops, and structural steel. Some anchorage connectors are built into connecting devices. These tie-back anchorage connecting devices will be addressed in detail later. The only form of body wear acceptable for fall arrest is the full body harness. The harness style should be selected based on the type of work being performed and the overall work environment. The full body harness offers an inherently high safety factor since fall forces are distributed throughout the body over many webbing components, including chest, shoulder, waist, and legs. In addition to distributing forces throughout the body, a properly fitted full body harness keeps the worker suspended upright while awaiting rescue. This is due to the sliding back D-ring, which slides along the webbing to the back of the neck once a fall occurs. OSHA states that potentially fatal suspension trauma can occur within minutes while waiting for rescue after a fall. Average fall rescue time is 15 minutes. When used, the Miller Relief Step Safety Device provides support and enhances blood circulation until rescue, permitting the ability to move and flex leg muscles. Small and lightweight, the Relief Step Safety Device attaches to any brand of full body harness. Utilizing 2 Miller Relief Steps, one for each leg, assures greater comfort until rescue is completed. While safety directors agree a comfortable harness fit is crucial to compliance, some workers lose sight of how important it is to follow directions when it comes to ensuring a snug fit with chest and leg strap adjustments and back D-ring positioning. In order to ensure proper protection, the full body harness must be worn properly. A simple 6-step guide can be followed that could save your life. Hold the harness by the back D-ring and shake to allow any tangled straps to fall into place. Unbuckle chest, leg, and waist straps. If the harness has a belt, unbuckle it too. Slip the straps over the shoulders so the back D-ring is located in the middle of the back between the shoulder blades. Pull the end of one leg strap between the legs and secure to the opposite end. Repeat this step with the other leg. If the harness has a belt, connect that after the leg straps. Connect the chest strap and position in the mid-chest area and then tighten shoulder straps. After all the buckles have been connected, adjust so that the harness fits snug but allows a full range of movement. Pass excess webbing under the loop keepers or web finials. Appropriate harness sizing influences compliance. Manufacturers offer various sizes as well as an array of styles for specific industries or activities. Side and front D-rings are typically used for positioning only. However, front D-rings or web loops can be used for ladder climbing and rescue. Body belts should be used for positioning and restraint only. Most regulations prohibit their use for fall arrest. Body belts do not distribute fall forces, but concentrate arresting shock in the abdomen, resulting in serious internal injuries. A connecting device is the critical link between the harness and the anchorage point. The connecting device manages the greatest forces during a fall. Connecting devices should be selected according to these criteria: type of work being performed and the characteristics of the environment, such as the presence of moisture, dirt, oil, grease, and electric hazards, as well as the ambient temperature. Potential fall distance.
Shock-absorbing lanyards expand when arresting a fall, while fall limiters and self-retracting lifelines lock up quickly to reduce the amount of fall clearance required below the work surface.
A personal fall arrest system should be designed and tested as a complete system. Components produced by different manufacturers may not be interchangeable or compatible. Selection criteria should also include a close look at product quality. For example, OSHA regulations call for limiting fall forces on an individual wearing a full body harness to 1,800 pounds. Most reputable lanyard manufacturers state maximum arrest force on the label of the lanyard. While OSHA regulations are the law and are enforced by a federal agency, ANSI standards are self-enforced by individual manufacturers. There is no enforcement body and no inspectors. The buyer cannot take stated performance per ANSI guidelines for granted. Always check with the manufacturer for documented proof. When attaching the connecting device to the harness, attach to the back D-ring only. If other D-rings are integrated on the harness, their use is for positioning or restraint. Shock-absorbing lanyards are required for a fall arrest system. Non-shock absorbing lanyards are for positioning and restraint only. While both will arrest a fall, the maximum arresting forces when used together with a full body harness needs to be less than 1,800 pounds. This is extremely difficult to achieve using a lanyard without a shock absorber. A test fall of a 220-pound mannequin dropping 6 feet with and without a shock-absorbing lanyard demonstrates the forces on the body. Without shock absorption, forces exceed 3,000 pounds, causing the head to snap back and the body to bounce at the instant of arrest. With a shock-absorbing lanyard, deceleration is much smoother and more controlled, and fall forces are contained to 900 pounds. Shock-absorbing lanyards feature pack or tubular designs, specially woven inner cores that smoothly expand to reduce fall arrest forces. Lanyards are available in steel, rope, and webbing. Never tie a knot in any web or rope lanyard. It reduces the strength by 50%. Double-leg shock-absorbing lanyards provide 100% tie-off fall protection. If one leg is not used, it should be connected to a pull-free lanyard ring on the harness and never be attached to any permanent fixture on a harness such as a side D-ring. All Miller brand harnesses include pull-free lanyard rings, designed for storing a lanyard or extra lanyard leg when not in use. Fall limiters and self-retracting lifelines, sometimes referred to as retractables, yo-yos, and seatbelts, are approved alternative connecting devices to shock-absorbing lanyards. While traditional shock-absorbing lanyards allow up to 6 feet of free fall distance before activating, self-retracting lifelines require less than 2 feet. Shorter activation and arrest distances reduce the risks of contact with the ground or lower level obstructions and allow for easier rescue in the event of a fall. Fall limiters and self-retracting lifelines are available with working lengths ranging from 6 to 175 feet. Self-retracting lifelines are durable, heavy-duty devices that have webbing or cable wound on a brake drum that extends as the worker moves away from the anchor point and retracts as he nears the anchor point. Personal fall limiters are lightweight web connectors that require less fall clearance and offer optimal mobility while preventing tripping hazards. They may be attached directly to the back D-ring or used as a traditional retractable lifeline. Double leg units are also available for 100% tie-off fall protection. Tie-back lanyards are a type of connecting device available as a lanyard or personal fall limiter that have a special snap hook and high-strength webbing that is designed to tie back anywhere along the lifeline. This all-in-one lifeline and anchorage connector increases safety and reduces equipment required on the job site. Only special snap hooks and webbing designed for use with tie-back lanyards are acceptable. Vertical lifelines are connecting devices available as rope or cable and used in conjunction with rope or cable grabs. These grabs are designed for hands-free operation, easily sliding up or down a lifeline as the worker moves, but instantly locking in place in the event of a fall. Common applications include roofing, window washing, and fixed ladder climbing. Connecting devices are the most critical components in surviving a fall and must be carefully chosen, properly used, and routinely inspected to ensure optimal performance and worker safety. Fall clearance calculations are vital in selecting proper anchorage points and connecting devices, and to avoid striking a lower level or obstruction in the event of a fall. Free fall distance should be limited to the shortest distance possible. This is never more than 6 feet when using a shock-absorbing lanyard, unless using equipment designed specifically for free falls over 6 feet.
When calculating fall clearance required for a shock-absorbing lanyard, the following variables must be considered: the original length of the lanyard, the maximum elongation after shock absorber deployment, the height to the worker's back D-ring, and a safety factor of 3 feet. When the amount of fall clearance is limited, a self-retracting lifeline is recommended. Some retractables require as little as 5 feet of fall clearance from the work surface to the next lower level or obstruction. While fall clearance is calculated from the anchorage point for a shock-absorbing lanyard, fall clearance for a self-retracting lifeline is often calculated from the work level. When calculating fall clearance for a self-retracting lifeline from the work level, the following must be considered: maximum fall arrest distance and a safety factor of 3 feet. Always know your fall clearance when selecting your connecting device.
To maintain service life and high performance, each harness and connecting device should be visually inspected before each use and regularly inspected by a competent person as defined by OSHA. Following these instructions may still necessitate removing the harness or connecting device from service prior to the expiration of the 5-year life expectancy guideline. Likewise, proper adherence to the inspection and maintenance criteria may extend the useful life beyond 5 years. Ultimately, it is the responsibility of the end user to determine when a harness or connecting device is unfit for use and should be removed from service. When not in use, products should always be stored at room temperature, away from chemicals, moisture, and ultraviolet light. To maintain proper service life and high-performance fall protection equipment, anchorage connectors, body wear, and connecting devices must be inspected regularly. Grasp the harness webbing with hands 6 to 8 inches apart. Bend the webbing in an inverted U as shown. Surface tension on the webbing will reveal damaged fibers or cuts. Follow this procedure for the entire length of the webbing on both sides, looking for frayed edges, broken fibers, pulled stitches, cuts, burns, or chemical damage. Check the D-rings and other metal parts for corrosion, distortion, cracks, breaks, and rough or sharp edges. The D-ring should pivot freely. Inspect for any unusual wear, frayed or cut fibers, or broken stitching of the D-ring attachments. Pads should also be inspected for cracks, excessive wear, or other signs of damage.
Inspect buckles for unusual wear or distortion, fibers around buckle attachments, or distortion.
Mating and friction buckles should not be bent or distorted. The outer and center bars must be straight. Tongue buckles should be inspected for heavy wear, especially loose, broken, or distorted grommets. Webbing should not have additional punched holes. The tongue should overlap the buckle frame and move freely. Quick connect buckles must be free of debris and engage properly. The outer and center bars must be straight. Inspect fall arrest indicators located on the back D-ring pad for signs of activation. Remove from service if broken or stretched between any of the pairs of arrows. When inspecting lanyards, Work from one end to the other using a slow rotation. Check snap hooks for cracks, corrosion, or distortion. Keeper springs must have sufficient force to close firmly. The snap hook locking mechanism should keep the hook's gate securely locked. Thimbles must be firmly seated in the eye of the splice, not displaying any loose or cut strands. There should be no sharp edges, distortion, or cracks around the edges of the thimble. Always wear gloves when inspecting a wire rope lanyard. While rotating, watch for cuts, frayed areas, or unusual wearing patterns on the wire. While bending webbing over a pipe, inspect for cuts, snags, or breaks. Swelling, discoloration, cracks, and charring are obvious signs of chemical or heat damage. Look closely for any breaks in stitching and inspect the lanyard warning flag for signs of activation. When inspecting a rope lanyard, rotate the entire length while looking for fuzzy, worn, broken, or cut fibers. Diameter of the rope must be uniform. Outer portions of the pack should be examined for burn holes and tears.
Stitching at attachment points
Must be free from loose strands, rips, deterioration, or other signs of activation. Lanyards with a shock-absorbing inner core should be examined for signs of deployment. A warning flag will indicate if the product has been used to arrest a fall. If the flag has been activated, it must be removed from service. Before every use, inspect the unit's housing for loose fasteners and bent, cracked, distorted, worn, malfunctioning, or damaged parts. Test lifeline tension by pulling it out several feet and allowing it to retract. The lifeline should pull out freely and retract all the way back into the unit. Do not use the unit if the lifeline does not retract. The lifeline must be checked regularly for cuts, burns, corrosion, kinks, frays, or other signs of wear. The braking mechanism can be tested by applying a sharp, steady downward pull on the lifeline. There should be no slippage, and when tension is released, the brake should disengage and the lifeline should retract into the housing. Do not use the unit if the brakes do not engage. Make sure the snap hook locks and the swivel operates smoothly. Check for any signs of damage to the keepers and any bent, cracked, or distorted components. Make sure the carabiner is properly seated and in the lock position between the attachment point on the device and the anchor point. Each year, hundreds of thousands of injuries and deaths are attributed to work-related falls. The good news is that with the proper fall protection equipment and training, these tragedies can be prevented. Fall prevention in the workplace begins with a commitment to safety. Both management and employees must be thoroughly committed for a fall protection plan to be effective. Understand all applicable OSHA regulations and ANSI and CSA standards regarding fall protection before using equipment. Take the time to ensure your workplace is a safe place. Identify possible fall hazards. Be committed to safety. Develop a fall protection plan and provide proper training. Fall protection equipment should be used only after proper training from a competent person. Employers should provide training for prompt rescue should a fall occur. Rescue procedures should be reviewed as a part of the company's regular safety training program. Read all instructions and warnings contained on safety products and in the packaging before using any fall protection equipment. All fall protection equipment should be carefully inspected before each use. If any damage is detected, the equipment should be removed from service. Attach in a manner which will limit a free fall to the shortest possible distance and make sure there is adequate fall clearance in the event of a fall. Use only the back D-ring on a full body harness for fall arrest. Other D-rings are for positioning and restraint only. Miller brand fall prevention and protection equipment provides your workers with the highest level of safety, comfort, and ease of use. Miller Training provides professional fall prevention and protection training, including competent person training programs. Training applies to all brands of fall protection with no sales pitch, just professional training for a safer workplace and compliance with governmental regulations. If you have complex fall hazards that cannot be easily met by conventional methods, contact Miller Engineered Solutions. They custom design and install permanent fall arrest systems. Their services include design, installation, testing, and systems use training.